Alright, so I've got a really nice differentiation question here. It contains some iteration stuff as well, which is really easy. But I'm going to go through it anyway. But the main focus for this video will be the differentiation. So pause the video, have a go, see if you can get it right, and I'll go through the work solution. Okay, so let's just kind of read the question first and what it's asking. So we get given a function of y, which is equal to 2x squared minus 3 all times by tan to the half x. And we have this domain here, which we need to keep a note of. Now the first question, nice and easy. Find the exact value of x when y is 0. So this is 1 mark, so you can literally just write the answer down and you'll get the mark. But for the sake of the video, I've kind of written a lot just to explain it. So if y is equal to 0, that would mean that this has to equal 0, this function, and this function also has to equal 0, because these are two separate functions being multiplied together. And the only way that y can equal 0 is if one or both of those functions were equal to 0. So let's do that. So let's set 2x squared minus 3 equal to 0. So I've done that here. And then once you solve that, you end up with x equals plus minus root 3 over 2. Make sure you don't forget the plus minus as well. That's really important. But here, because of the domain of x is between 0 and pi, this will not be suitable, this minus root 3 over 2. So we can kind of neglect that, we can discard it. So we end up with x equals root 3 over 2. So that's our first kind of value. And notice how the question said, find the exact value, not the exact values. So that would kind of hint that that's your answer. But it's good to just check the tan a half x as well, just in case. So we're going to do that. So again, we set tan a half x equal to 0. We solve that. So we do arctan of 0, which is obviously just 0. And then that is equal to a half x, and because it's a half x, we now need to adjust our domain. So our domain before was 0 and pi, but now because it's a half x, the domain would switch from 0 to a half pi because it's a half x now. So when we do that, we don't get any solutions within this domain, and the reason for that is because if you get a half x is equal to 0 and you try and add pi, because remembering with tan you always add pi to find the other solutions, when you do that you're not going to get anything in this range, because the minimum value you can get other than 0 is pi, and that is not in the domain. So there's no solutions for tan for that part, which means our only x value is root 3 over 2, which is what we thought. Nice, very easy. Okay, so this part now is where it gets a bit tricky. So it's saying that given that dy over dx is equal to 0, when x equals alpha, show that 2 alpha squared minus 3 plus 4 alpha sine alpha is equal to 0. So the first thing we need to do is obviously differentiate it. And now we need to ask ourselves, okay, how would we differentiate such a horrible looking function? So, like I said before, we have two different functions here, and these are both being multiplied together. So we need to do the product rule. And not only that, but within this part of the product rule, we also have a function inside of a function. So we have a half x, which is one function, and then that's all inside of a tan function, which is another function, which means we have to use a chain rule. So the product rule is you differentiate the first kind of function, you leave the second, then you leave the first one and you differentiate the second. So that's how you do it, or you could do it the other way around as well. So let's do that. So we're going to leave the 2x squared minus 3, because that's the first kind of function. And then we're going to integrate tan a half x. So the way you integrate tan a half x is by using the chain rule. So tan x differentiates to sec squared x, right? But we don't have just tan x, we have tan a half x. So the differential of that is sec squared a half x, right? Because we keep the half the same. But remember, with the chain rule, we have to differentiate whatever's in the bracket and then times it by our original differential. So what I mean by that is we had sec squared a half x, and then when you differentiate a half x, we just get a half, right? And then you times a half by this thing here, and you end up with a half sec squared a half x. So that's the first part of the product rule. The second part now is just doing the opposite. So you differentiate this, and then you leave the tan a half x the same. So that's really easy. Just differentiating this, you get 4x using all your one techniques, and then obviously leave tan a half x the same. So once you've done that, you end up with that horrible looking thing. So the next thing you do is you use the information in the question. So I said dy over dx is equal to 0 when x equals alpha. So you just rewrite it like this, like I've done here. Now in terms of what the question wants us to write it as, we should notice two things. The first thing is that we've only got a sign here. So we don't have a sec or a tan, we just got a sign. And the second thing is that it's sine alpha, it's not a half alpha, which should scream to you by which you have to use the double angle formulae. So that should be really obvious because you're going from a half to 1. So you're doubling that angle, you're doubling the argument, which means you need to use the double angle formulae. So let's just firstly try and get it in terms of sine first, rather than sec and tan. So the first thing we do, actually before we do that, one quick thing to mention is because it's equal to 0, we can take the 4 alpha tan half alpha to the other side. I just found it easier to do that. You don't have to, but that's just my preference. And then I also got rid of this fraction by timesing everything through by 2 to get this. So now we can change the tan and the sec into things that we can work with to turn into sine. So tan obviously turns into sine over cos, right? And then sec is just 1 over cos squared. Making sure that we remember to include the half alpha. That's very, very important. So once you've kind of converted it into that, and also with practice, you'll kind of get really quick in recognizing what you need to turn it into. So don't worry too much if it takes you a while to start off with. But once you do more and more practice, it will get better. So once you end up with that, you should notice that you can cancel a cos half alpha on each side. So I got rid of one of these, and then obviously because this is cos squared half alpha, I also got rid of one of those to end up with this. Now the next thing we can do is we can times everything through by cos a half alpha. And if we do this, we end up with this. Now this looks really messy, but you should notice something, which is the double angle formula, like I said. So I've written here sine 2 alpha equals 2 sine alpha cos alpha. That's just a fact that you need to know. That looks very, very similar to this. The only difference is instead of just 1 alpha on each of the sines and the cos, it's a half alpha. But the same principle still applies. So from the double angle formula, you can just half the argument being the angle inside the trig function, by 2. So you can get sine alpha equals 2 sine a half alpha cos a half alpha. So as you can see, I've literally just divided each of the arguments by 2. So this now looks very, very similar to what we have here. The only thing is we have the 8, the minus 8. So all I did was times each side by minus 4 to get minus 8 sine a half alpha cos a half alpha, which is exactly what we need, obviously other than this alpha here. But we could just write that like in terms of what we get. So we end up with minus 4 sine alpha equals minus 8 sine a half alpha cos a half alpha, and we can directly sub that minus 4 sine alpha into this, not forgetting this extra alpha here. So we get minus 4 alpha sine alpha equals 2 alpha squared minus 3. Again, you don't really need the brackets, so I just wrote them in anyway. And then finally all we can do is just we add the 4 alpha sine alpha onto this side here, and we end up with this, which is what is required. So that was quite tricky, but well done if you got that. That's really good. So the next couple parts are very, very easy. It's just iteration. And the way you do iteration is by firstly, so let's read the question. So the iterative formula, xn plus 1 equals 3 over 2xn plus 4 sine xn. And then that can be used to find an approximation for alpha. So taking x1 as 0.7, find the values of x2 and x3, giving each answer to 4 decimal places. This is very important. Highlight this, because a lot of people tend to forget that and you'll lose a mark or even a couple marks like doing this and forgetting. So make sure you mention that. And also, the way they kind of got this from this is they literally just rearranged it in terms of alpha, and then they replaced alpha with xn. Yeah, so that's how you're meant to do it. So if you get a question like that, and there are kind of types of questions where you need to come up with your own iterative formula, that's all you do. You just rearrange it in terms of alpha or x or whatever you get. So taking x1 as 0.7, find the other two. So the first thing you need to do, then there's a very specific way of like setting this out. So you put into your calculator 0.7 and then you just press equals. So nothing would happen, but you just press equals. The next thing you do is in your calculator, you put this expression in to the calculator, but obviously replacing xn with answer. So using the answer button in your calculator, you replace that. Then you just press equals and you end up with x2. And then you can press equals again and you end up with x3. So I'll show you. I've taken a screenshot of my calculator. So as you can see here, I did before this, I set 0.7 and then press equals. And then all I did was I set the fraction that I gave. And then instead of the xn, I just replaced it with the answer button. And then I press equals to find x2, which I've written here. And then I pressed it again to find x3, which I've written here. And in terms of the way you set your answer out, you need to set it out like this. So for the first kind of term that you're finding, you need to show that you've plugged in 0.7 into your expression. So you write the whole expression, show you plugged in 0.7, and you end up with this. But with any term after that or any kind of value that you're trying to find after that, you don't need to do that. You can just directly press execute on your calculator and just write down the answer, which is what I've done here. And that's it. That's all it is. Then the last part, by choosing a suitable interval, show that alpha equals 0.7283 to 4 decimal places. So with these types of questions, again, very, very easy. All you do is you find the upper and lower bound of this thing that is given you. So the upper bound, using GCSE knowledge, is 0.72825 and the upper bound is 0.72835. And then all you need to do is you can plug the upper and lower bounds into either this or this. It doesn't matter. And then you have to show that there's a sign change. So I'll show you what I mean. So here I found the upper and lower bound. And then this is my interval that I'm using, right? So when I set alpha is equal to the lower bound, I end up with this once I plugged it into this expression here, right? So I end up with minus 0.0005. And that is a negative number. Whereas if I plug in the upper bound, I end up with this. Again, subbing it into the same expression, I get 0.00026, which is greater than 0. So because there's been a sign change, that means that the value of alpha lies within this interval here. So in your reasoning, you have to say there's a sign change, but not only this, you also have to say that the function is continuous. You would lose a mark if you don't say that. And continuous basically means that on the graph, so say if I plot any random graph, the line, it just continues. It doesn't like break up or there's no asymptotes or anything like that. So that's what continuous means. And that's everything. That's literally 2 marks right there. So I think these 4 marks here are very, very free. This mark, obviously very free. It's only the differentiation that was quite difficult in this question. But I hope you found it useful. And if you got it wrong, don't worry. Just make sure you learn from your mistakes and keep on practicing. If you're interested in tutoring, make sure you let me know by dropping me a message. I offer services in maths, biology and chemistry, both at GCSE and A-level. And make sure you obviously like, follow, comment and share.